Good evening, everyone. In the last session, we have started our discussion related to Kubernetes. So we completed the discussion related to introduction of the Kubernetes and advantages of going for Kubernetes, the differences between Docker Swarm and Kubernetes. Kubernetes is an orchestration engine. It is used to manage containers of our application. Kubernetes is also called as K8s. It is open source platform and it developed by Google using a Go programming language, and Google donated the Kubernetes to CNCF in 2014. The first version of the Kubernetes released in the year of 2015. We can consider Kubernetes as replacement for Docker Swarm. So Kubernetes is not the replacement for the Docker. Kubernetes is replacement for Docker Swarm. Good, because Docker Swarm is also orchestration engine. Kubernetes is also orchestration engine. So there are several differences when we go for Docker Swarm and Kubernetes. In the Docker Swarm, scaling the containers is a manual process, whereas in the Kubernetes, it is automated concept. Okay. Docker Swarm is not recommended for production deployments to scale the applications. Kubernetes is highly recommended for production deployments of our application. Next, we discussed about Kubernetes architecture. What are the components that are available in the Kubernetes? So mainly Kubernetes will follow cluster architecture. Master node will be available and worker nodes will be available. Master node is also called as control plane. It is going to manage the cluster. It is going to assign the work to the worker nodes. In the worker nodes, we have kubelet, kube proxy, Docker engine, Docker runtime, containers, pods. In the master node or in the control plane, we will have API server, scheduler, controller manager, etcd. We can interact with this Kubernetes cluster in two ways. One is by using user interface and the second one is by using kubectl. Kubectl is a command line software which is used to communicate with our Kubernetes architecture. Got it. Worker node and master node. So API server is going to receive our request and it is going to store the data in the etcd. Etcd is a data store of the Kubernetes. So when the request got stored in the etcd, scheduler is going to check that is that request is scheduled or not. If it is not scheduled, then scheduler will talk to worker node by using kubelet. So kubelet is a node agent. It is going to identify the resources availability in the worker node, and the kube proxy will provide the network rules to communicate with the worker nodes and pods. Docker engine is used to run the containers, and containers will be grouped together for managing easily for management purpose. So the logical unit of containers is called as a pod. Pods are two types. So single container pod we can use, or multi-container pod also we can use. Within the pod, we can run only one container, or we can run one container, or we can run multiple containers also. So whenever the task got scheduled, controller manager is going to use the controller to perform that action. So this is the architecture of our Kubernetes. Next one, Kubernetes cluster setup. So we can work with the Kubernetes cluster in two ways. So one is self-managed Kubernetes cluster. Another one is managed Kubernetes cluster. Self-managed Kubernetes cluster means we have to set up the things on our own. We need to set up this cluster on our own. That is self-managed Kubernetes cluster. To go with the self-managed Kubernetes cluster, again, we have two options. One is Minikube, second one is Kubedium. If you go for a Minikube, you can set up a single node cluster. That is for practice purpose only for the beginners. But in the real time, we are going to set up the Kubernetes with the multi-node cluster. To set up the multi-node Kubernetes cluster, we are going to use Kubedium software. Okay, that is if you want to manage on your own. If a client is ready to pay the money for the infrastructure in the cloud, then we can go for managed Kubernetes cluster. Every cloud platform is providing a platform to run our Kubernetes cluster. So that cluster management will be taken care by cloud providers. Like AWS provided EKS, Elastic Kubernetes Service, Azure provided AKS, GCP provided GKE, Google Cloud, Google Kubernetes Engine, and IBM Cloud also provided one cloud that cluster, that is IKE, IBM Kubernetes Engine. So it's up to project requirement, whether we need to set up the cluster on our own or we need to go for managed Kubernetes clusters. Are you guys clear with my point? Good, fine. So now let's start with our self-managed Kubernetes cluster. So in order to go with self-managed Kubernetes cluster, I'm going to take 3 Ubuntu virtual machines. One machine I'm going to use as a master node. 2 machines I'm going to use as worker nodes. In the master node and worker node, I'm going to install both Docker and Kubernetes because master node and worker node should have Docker container, Docker runtime, and Kubernetes platform. And in the master node, I will install Kubedium as well as kubectl. So kubectl is a CLI interrupt CLI which is used to execute our Kubernetes commands. So I have shared one document for installation purpose. Guys, did anybody tried this? Are you guys able to set up the Kubernetes cluster in your machines? Is it working? Yeah, now let me do this setup, guys. So let me do this setup in my local. I am using Mumbai region. As I told you, for Kubernetes, we need to enable a lot of ports. So I'm going to use security group. I'm going to use document is empty. Security groups, EC2 dashboard, security groups. There is some issue. Let me log out and log in again. Let me log in into my AWS account. Guys, observe carefully how I'm going to set up self-managed Kubernetes cluster. EC2 dashboard. I'm in the Mumbai region. Security groups. Yeah, there are several security groups available. I created one security group, my Kubernetes security group. In this security group, if you observe, I enabled inbound rules. SSH I enabled 22 and all traffic I enabled all traffic, any port number, because there are 4 to 5 port numbers we need to use for Kubernetes cluster. We will talk about those port numbers in the coming classes. So currently I'm enabling all the traffic. Okay, fine, good. Now let's go with the installation process. Here I'm going to take first master node with the medium instance because it will give 4 GB of RAM. Go to instances, launch one instance. So in my Mumbai region, currently there are some servers are available. So these are not for us. So I'm going to create new servers now. Instance state is equal to running. Currently no machine is running. Launch instance. I'm going to take Ubuntu server with the T2 medium. For master, I'm taking T2 medium. We are going to get 4 GB of RAM. Instance details, only one master node I'm going to take. Storage default 8 GB. Tag, I'm going to take it as master node. K8s master. Name K8s master node. Okay. Configure security group. I'm selecting the new security group I have created, my Kubernetes security group. TCP 22, TCP SSH protocol opened with 22 and all traffic is also enabled. Review and launch. Launch this. Linux key pair. You can use the same key pair for multiple instances, no issue. Launch the instance. Okay, one instance got launched. Kubernetes master node. Now I need to launch 2 worker nodes. For launching the worker nodes, we can use micro instances which are free tier eligible, no problem. Launch the instances. So those instances also I'm taking Ubuntu servers I'm taking. T2 micro instance details, number of instances 2. So I don't want to create one after other. At a time I want to launch 2 instances. So I'm giving two instances. Storage default 8 GB. Tags I will change them later. Security group. Yeah, that security group we have created with the Kubernetes name. Review and launch. Click on launch. Same key pair I'm using for this also. Launch the instances. Yes, 2 instances launched. Now instance state is equal to running. Currently one instance is ready. 2 more instances are getting created now. Let's wait. Yeah, one instance got started. One more instance should come. Yep. Now see, total 3 instances are running. Let me rename them. Kubernetes worker node 1. Save this. Then let me rename this one also. Kubernetes worker node 2. Worker node 1 and worker node 2. So total 3 instances are ready. Now here there are some commands. Those commands are common for both master and slave. I mean to say both master and worker. 3 instances are available. In the 3 instances, we need to execute these common commands. After that, we need to execute a few commands only in the master. Okay, let me do this activity, guys. Let me connect to the master node first. Click on this public IP. Go to MobiXterm. Remote host. Username, default username will be Ubuntu. Use this PEM file, Linux PEM file. Okay, so this is my master node. Okay, guys, I'm changing the tab color. So to understand it better, my master node tab color I have given as a red so that easily we can differentiate that. So first let me go with these commands in the master. Step 1, we need to install the Docker. So before installing the Docker, let's update the existing packages. Sudo apt get update the existing packages, then install the Docker using docker.io. Docker.io. Yes, install it. Once it is installed, you can check the version of the Docker. Yeah, Docker installed. Add the current user to the Docker group. Then start the Docker. Enable the service for the Docker so that when we restart our machine, Docker also will start by default. So step 1 is completed. Docker got installed. Then we are going to install the Kubernetes. So install curl package. Curl is used to hit the URL. So I have installed the curl first. Then add the GPG Kubernetes key with this below command. I have added that key. Then add Genial Kubernetes repository. Press enter to continue. Yep. Once it is done, then install Kubedium, that is Kubernetes admin, which is used to set up our cluster. Kubedium software. Yes, install it. Once it is done, you can execute this command to check these things installed properly or not. Yeah, Kubedium, Kubelet, kubectl, Kubernetes CI, all these are installed. They are on the hold. You can check the version of the Kubedium. Yeah, Kubedium version it is displaying. Disable swap memory. Disable that swap memory. Once it is done, then systemctl daemon reload. Systemctl start kubelet. Kubelet is a node agent. Then enable kubelet service as a startup service. So these commands are executed in the master. Same commands we need to execute in the worker also. Right. Now let me connect to worker node 1. Now I will do the installation parallelly in both machines, guys. Observe. Remote host username will be Ubuntu. By default, take the private key PEM file, open, OK. So the red color one is the master, and here this is my worker node. Let me set the tab color as some blue. Okay, this is one worker. Let me connect to another worker also. Worker node 2, copy the public IP. Remote host username is Ubuntu. Settings, private key, Linux PEM file. Okay. So this is my worker node 2. Let me change the color, set the tab color. Let me give this as some pink. Okay. Red, blue, pink. Red is my master node. Okay. Blue is my worker node 1. Pink is my worker node 2. Pink is my worker node 2. Now these commands, the common commands I need to execute in both workers. So observe sudo apt get update. The same commands I'm going to execute in both machines at a time so that we can save our time. What are the commands that we need to execute? Both commands I'm going to execute. Commands I'm going to execute in both worker nodes at a time. Yeah. Docker version, no need to check it. Yes. Now user mode, it is still installing in the second node. Done. Yes. Start the Docker. Start the Docker. Now enable the Docker as a service. In both worker nodes, I'm enabling Docker as a service. It is done. Now let's install the Kubernetes here. Install curl package manager. So curl, I'm installing the curl which is used to hit the URLs. Yes. Once curl is installed, add the key. Then repository of Kubernetes. Done. Then install Kubedium, kubectl. Actually, kubectl is required for the worker nodes, or kubectl not required for the worker nodes. Kubectl is not required for the worker nodes. We can ignore that. Kubectl not required for the worker nodes. We can ignore that. Basically, kubectl will install only in the master node. All right. Now installing this. Once it is done, then you can check that they are installed properly or not. Okay. Yeah, all are fine. Next, check the version. Yeah, good. Disable the swap memory. If the disk is full, it is going to write to that secondary memory. I don't want to do that. I'm disabling that swap memory. Then daemon reload. It is done. Then start the kubelet. Start the kubelet. Yeah. Once the kubelet is started, then enable kubelet service so that whenever you stop and start the machine, it is going to start along as a service by default. With this, common commands execution completed in all the three nodes, master, node 1 and node 2. So with this setup is completed, now we need to execute few commands only on the master machine. So running and deploying the Kubernetes by using kubeadm. Okay, this kubeadm I'm going to initialize only on master machine, not on the worker. Sudo kubeadm init. It is used to initialize our kubeadm software. Kubeadm is used to set up self-managed multi-node cluster. So if you see in here, what is the kubeadm? Kubeadm is used to set up multi-node cluster. Minikube is available for single node, but kubeadm is used to set up multi-node cluster. That kubeadm I'm going to initialize only on the master machine. Got it, guys? So it is taking some time. We have to wait for that. Kubeadm is getting initialized on the master node. Kubeadm is getting initialized on the master node. Yes, fine. Guys, once kubeadm initialization got completed, it is giving some instructions. We have to read it. Your Kubernetes control plane has initialized successfully. Control plane nothing but master node. To start using the cluster, you need to run the following as a regular user. You need to execute these three commands. Alternatively, if you are the root user, you can export this admin conf file. You should now deploy a pod network to the cluster. kubectl apply, you can deploy it. Then you can join any number of worker nodes by running the following on each root. Okay, each as a root. So if you see, once your control plane has initialized by using kubeadm, we need to execute these three commands as a regular user in the master node. After that, we can use this token. We can use this token to join any number of workers. We have two workers. Those two workers should join with our cluster. So first, let me execute these three commands, which they have given as a regular user execution. Okay. mkdir. So let's see here, whatever they have given, mkdir -p home space dot kube. Okay, yes, done. Then kube.config file, sudo cp-i etc kubernetes admin.conf, then home.kube.config. So kube.config file is getting created, which contains our cluster information. Then change the permissions. Done. Once it is done, we can say that our cluster is ready. But currently, do we have any nodes joined in our cluster? kubectl get nodes, check it. Do we have any nodes joined in our cluster? As of now, did we ask the workers to join the cluster? Did we ask the workers to join the cluster, or workers are not joined the cluster as of now? Come on, guys. Workers joined with our cluster, or workers are not joined with our cluster? Workers are not joined with our cluster. How to join the workers to the cluster? How to ask the workers to join the cluster? Come on. How to ask the workers to join the cluster? Respond. How to ask workers to join the cluster? By using token. Okay. So what is the token we use? What is the token? So you can get the token by using kubeadm token create print join command. Okay. So if you want to join the workers to the cluster, you need a token. So it is giving this token. Now copy this token, go to the first node. So you need to execute this token as a root user. I have given the command clearly. So execute this command, you will get a token. Add the worker node. Add the worker node to form a cluster by executing the token in the worker nodes as a root user. So sudo token I have copied, I'm executing this token. Now it is going to join with the cluster. Now this is my second worker node, sudo join. Good. So these two workers, blue worker and pink worker, trying to join with our cluster. They are joining with the master node. I executed token. So once it is done, they are telling that execute kubectl get nodes command to see what are the workers available. Now can you see two workers are joined? So now kubectl get nodes. kubectl is a CLI interface. kubectl is a CLI interface which is used to execute the commands in the Kubernetes cluster. So now currently, how many nodes are available in our cluster? How many nodes are available in our cluster? Total 3 nodes available in our cluster. So you can see this, 3 nodes are available in our cluster. One node is acting as a control plane. What is the meaning of control plane? Control plane is nothing but master node. Okay, the remaining 2 are normal nodes. They are nothing but worker nodes. You can check the IP addresses. So check the private IP address of the master node. What is the private IP? 65 172.31.40.65. That is master node IP address, private IP. Now let's go for node 1, private IP 247. So you can see 247 is joined as worker node. Then let's see worker node IP address, worker node 2 IP address 85. 85 also joined as a worker node. So with this, can we say our cluster setup is ready? It is managed cluster or self-created cluster? It is a provider managed cluster, or it is a self-created cluster? Self-created cluster. Which software we are using to set up this cluster? Our cluster is a single node cluster, or our cluster is a multi-node cluster? Our cluster is a single node cluster, or our cluster is a multi-node cluster? Our cluster is a multi-node cluster. Which software we used to set up this? We used Kubedium. we use Kubedium. Very good. Now guys, in the real time, we are going to set up this Kubernetes clusters. Right here, master node is available. For this master node, we have 2 worker nodes. One is a master node and 2 worker nodes are available. Instead of 2, you can take multiple worker nodes also, depends upon the requirement. So this is our master node. Master node is also called as control plane. This is worker node 1, worker node 1 and worker node 2. Okay, this worker nodes joined with the master node by using join token. We have taken a join token and we used them. We used the join token in the worker nodes. They are joined with the master node. So this is also called as control plane. This is also called as control plane. Now we are going to use kubectl to execute the commands. Kubedium we used to set up this cluster. Now I want to deploy my application. Like I want to create some pods. I want to run my containers in the pods. I want to do auto scaling. I want to do replication factor. I want to execute some commands with the Kubernetes cluster to deploy my application. In order to do this, we need to use kubectl and we need to execute that kubectl commands in the master node. But is it recommended to connect with the master node directly by using SSH and executing the commands in the master node? Is it recommended approach? Is it recommended approach? Is it recommended approach to connect with the master node directly. In the project, multiple developers will be available, multiple DevOps team members will be available. Can we give the access for everybody to manage the master node of the Kubernetes cluster? Is it secured? Is it secured or it is not secured? Can we give access for master node for every developer to use SSH directly? They can connect with the master node, they can execute the commands on the master node directly? Will you give the access for the master node for the people? Will you give access for the people? No, it is not at all recommended. It is not at all recommended. Got it? So that's why what we do in the real time is we are going to set up one remote machine. We are going to set up one remote machine. In that remote machine, we are going to install just kubectl. We are going to set up one remote machine. In the remote machine, we are going to set up the kubectl. This remote machine will connect with the master node just to execute the commands. That's it. Not load balancer. Why load balancer? So here my Kubernetes cluster setup is done. 2 worker nodes available, 1 master node is available. Now I want to deploy my application. It is not recommended to perform the operations directly on the master node machine by using SSH directly. Now I connected to Kubernetes cluster. I connected to worker nodes. So can we ask every team member to use putty or MobiXTRM and connect it to the master node and execute kubectl commands directly? Is it recommended? It is not recommended. So that's why what we are going to do is we are going to take one remote machine. We are going to take one remote machine. That is another virtual machine we are going to take. In this virtual machine, we are going to install kubectl software. What is a kubectl? Guys, come on. What is a kubectl? What is a kubectl? It is just to execute the commands. It is just to execute the commands. Are you guys getting my point? We are just going to execute kubectl commands here. Okay, now let me create one more machine that is used to execute the commands of the Kubernetes cluster. You can execute the commands directly on the master node, but it is not recommended, guys, because in the team, everybody cannot access the master node because it is secured, right? We can't give the access for everybody to execute SSH commands directly on the master node. So that's why we are going to create one remote machine. In the remote machine, we are going to install the kubectl. From the remote machine, we are going to manage the Kubernetes cluster. We are not going to disturb this cluster. The cluster setup is done. We are not going to execute the commands on the Kubernetes cluster directly. The cluster is available. The cluster we will manage from another machine, remote machine. In that remote machine, we are going to install kubectl. Okay, so let me take another machine here. Let me take another machine. It is just for executing kubectl commands, guys. It is just for executing kubectl commands. So let me take one Ubuntu server or Red Hat Linux or Amazon Linux, anything is fine. Ubuntu T2 micro, add storage, adding the tag. Yeah, let me give this name as kubectl VM. kubectl VM. Security groups. Security groups. Review and launch. Click on launch. So this is just one kubectl virtual machine I have created. So what is the purpose of this machine? It is used to execute the commands of Kubernetes cluster. I don't want the people to connect with my master machine to execute the commands directly. So that's why I'm going to create one remote machine. In the remote machine, I'm installing kubectl. In the remote machine, I'm installing kubectl. Using the kubectl, I will manage my cluster from outside. Okay, right. Let me connect to that kubectl machine. In that, we need to install the kubectl software. Public IP. session, SSH, remote host, username is Ubuntu, private key, Linux PEM file. Okay. Now I connected to this machine. Sudo apt get update -y. Update the existing packages. Update the existing packages. Yeah, it is done. Now here I'm going to execute kubectl get nodes. What it is telling? First of all, this machine don't know what is a kubectl. So what I need to do in the remote machine now? In the remote machine, I have to install kubectl software. Okay, how to install kubectl software on the remote machine? How to install kubectl software on the remote machine? Let me give the commands to install kubectl on the remote machine. Let me give the commands to install kubectl on the remote machine. Okay guys, now in this installation only I'm going to add those commands. Yeah, we can access master node from remote machine using kubectl. Okay, so launch EC2 VM, install kubectl. So to install the kubectl, these are the commands we are going to execute. Take this command. This machine is in the black color guys. This is our kubectl machine which is going to communicate with the Kubernetes cluster. Total 4 machines are there. Red color tab machine is my master node. Blue color is worker node 1. Pink color is worker node 2. This black one is just one virtual machine. In that I am going to install kubectl. Execute this command. Execute this command which is going to get that kubectl. Then give the permission chmod. Then rename it. Then check the kubectl version. Okay, then make one directory in the current working directory, that is the .cube. In the .cube, here we need to keep cluster information. So we need to configure the cluster information because this remote machine should talk to the cluster. But where is the cluster? How to connect to the cluster? This you don't know. So for that purpose, what you need to do is take kube config file from master node. Take kube config file from the master node and keep it here. So in order to take the kube config file from the master, we are going to execute this command in the master node. Go to the master node, cat kube config file. The kube config file contains the cluster information. So we are going to copy this. We are going to copy this. This we need to keep inside this kube config file. Okay, where is the kube config file? This is our kube config file we are going to create. Go to insert mode, then take this kube config file from master node. By using this cat command, we are going to get that kube config information. Take this kube config information and keep it here in the remote machine. Okay, then just save it. Okay, now we have configured that information. Once we have done that configuration, then go to our remote machine, execute cluster info, execute cluster info kubectl get nodes, kubectl get nodes. So let me exit from here. Let me reconnect to this. Okay, clear. Let me check it. Is this configuration is updated properly? Yeah, cluster configuration is updated properly. So server is running in this location. So all the information is added. All the information is added. Okay. Get nodes. So that connection to the server was refused. Did you specify the right host or port? So let me check what is the port number available for this kubectl under security groups. Inbound rules, all the traffic is enabled, so there is no issue with that. So let's wait for some time. All the 4 instances are running. Let me exit. Let me reconnect to that machine, guys. Session SSH. Take the public IP, remote host, specify the username, which is Ubuntu, private key, Linux PEM file. Okay, good. kubectl version. Yeah, kubectl version it is displaying. Now kubectl get nodes. It is not connecting to that server. 6443 is the port number it is using internally. I have enabled all the traffic. I have enabled all the traffic. Let's try kubectl get namespaces, kubectl get nodes. Sudo kubectl get nodes. Let me enable only that particular port in the security group. 6443 in the inbound rules. Let me edit the inbound rule, custom TCP 6443 anywhere. Save the rule. Okay. Clear. Exit. Reconnect. kubectl get nodes. It should connect to that server that is refusing the connection. 6443 port. I have enabled it. Inbound rules. So custom TCP 6443 port I have enabled. Save it. All the traffic is also enabled. First of all, is it working in our master node? kubectl get nodes. So here also it is refusing our connection. kubectl get nodes. Yeah. So let me check it. Sir, first time, see here, some intermittent issue we are getting. First time when we have done this setup, we were able to get the nodes data, but currently now it is saying that connection is refused. So it's maybe due to some swap memory issue. Let me check it. Running Kubernetes locally via driver connection was refused. So let's check in the Kubernetes official documentation. What is the solution? Connection was refused. Yeah, this is what I'm seeing in the running Docker logs in the Kubernetes API server Docker process. I can run the following command and update the question kubectl cluster info. Yeah, and found I solved that issue by using this. Okay, let me execute this commands. Sudo -i swap of this, exit, then trace kubectl version. Okay, and you can type kubectl get nodes again. Still issue is not resolved. kubectl get nodes connection is refused. In the master node also it is saying that connection is refused. Did you specify the right host or port? Yes, port is specified correctly. This is amazing. It works. Sometimes it's like a back magic. We have already done this configuration, right? Mkdir sudo kubeconfig file override. Yes. Sudo chown. Okay, so we have tried all the possible options. kubectl get nodes. Connection is refusing. Okay. Let me restart the kubelet service. After that, kubectl get nodes. Yeah, now it is working. So once I have restarted that kubelet service, now it is giving me the nodes. Okay, in the master node, I'm able to get that. Now let me go to this node. kubectl get nodes. I'm working on the remote machine. I'm trying to execute this kubectl get nodes on the remote machine. So why I have created my remote machine, guys? Why I have created a remote machine? Come on. Already cluster is available. Why I have created another machine? What is the reason for that? For security issues. We don't want to give the access for the people to connect with the master node to execute the commands directly. Okay, so that's why I have created one remote machine. How we connected this remote machine to the master node? By installing kubectl. Only with the kubectl, it is not sufficient. You need to copy the kubeconfig file from, you need to copy kubeconfig file from the master node. Kubeconfig file. This kubeconfig file will contains the cluster information. Kubeconfig file will contain the cluster information. That kubeconfig file we are going to copy into our remote machine. Kubeconfig file we are going to copy into our remote machine. Okay. Now, once we copy that kubeconfig file into our remote machine, then this kubectl software is going to connect. It is going to connect with that machine. Got it, guys? So kubeconfig file is available. That kubeconfig file we are going to copy from that machine to our remote machine. Okay. Right. Kubeconfig file will be available. Kubeconfig file we are going to copy here. Now let me do cat of dot slash cube slash config. I'm going to override this content. So this is my kubeconfig file available in master node. We are going to copy this data and we are going to keep this in remote machine. We are going to copy this data and we are going to keep in the remote machine. Okay. So once we kept this in the remote machine, then we can see that the data got copied. The data got copied. Once the data got copied, that means it is having the cluster info. Now we can use kubectl cluster -info. Now say that Kubernetes control plane is running at this location. Core DNS is running at this location. So from this remote machine, am I able to access the cluster? How? Here, kubeconfig file, whatever the kubeconfig file is available here, I linked that kubeconfig file. I copied the kubeconfig file from my master node and I kept that in the remote machine. Kubeconfig file. Kubeconfig file I have taken from the master machine and I connected with the remote machine. I pasted that machine. I installed the kubectl and I have taken kubeconfig file and I kept the kubeconfig file here, so that this remote machine knows where is the Kubernetes cluster. Now kubectl is installed in the remote machine. Using this kubectl, I will execute the commands here in the remote machine. So the remote machine is going to execute those commands on the Kubernetes cluster. Now we will give the access for the people to connect with the remote machine to execute the Kubernetes commands. We don't give the access for the people to connect with the master node directly. So master node is available and worker nodes are available. Worker nodes are connected to master node. We don't give the access for the people to operate the master node directly by using SSH commands. So that's why we created a remote machine. Now see the steps here, how I have created my remote machine. How I have created my remote machine. We can access master node from a remote machine using kubectl. Launch new EC2 VM, install kubectl using below commands. Okay, so this is the first command. We are going to download the kubectl, change the file permission, then rename that, then check the version of this, then make one kube directory. This is used to keep our kubeconfig file. So create a kube directory, take kubeconfig file from the master node using below command, master node using below command, and copy that and copy that. Okay, so paste master node kubeconfig file data here. This command we need to execute in the master node. It is going to give you kubeconfig file. What is that kubeconfig file? Kubeconfig file contains Kubernetes cluster data. That cluster data we are giving to our remote machine kubeconfig file, so that remote machine can understand where the Kubernetes cluster is running. Take the kubeconfig file from master and keep it here. That is done. Once you have done this step, now if you execute kubectl cluster info, it is able to get where the cluster is running. It is able to get where the cluster is running. When I execute kubectl get nodes, it is getting all the nodes which are available in the Kubernetes cluster. In the Kubernetes cluster, 3 nodes are available currently. One node is acting as a control plane, nothing but master node. Remaining 2 nodes are acting as worker nodes. So total 4 machines are available. Red color machine is my master node. Blue color is my worker node 1. This pink color worker node 2. This black color machine, my remote machine. In the remote machine, I installed kubectl and I connected to that master node cluster using kubeconfig file. Are you clear with this process now? Are you clear with this process? How to set up Kubernetes cluster on our own? Self-managed Kubernetes cluster? Lot of commands we have executed. Lot of commands we have executed. Okay. Our cluster setup is ready. If you go for AWS EKS, if we go for AWS EKS, do we need to do all this setup or AWS will take care of this setup? Yes. Now you understand the power of cloud computing. Almost it took 1 hour to set up just a cluster, Kubernetes cluster. Just to 2 nodes we have taken, 2 worker nodes we have taken, 1 master node I have taken. As a best practice, I have created a remote machine to perform kubectl commands execution. Some people will execute the commands on the master node directly, but that is not recommended. In the real time, you will not, as a developer or as a DevOps engineer, we will not get the direct access for the master nodes, guys. Basically, for developers, we don't give the access for the master node to execute Kubernetes commands. For the developers, we will create a remote machine. In the remote machine, we will install the kubectl. We will give the remote machine access for the developers so that they can execute kubectl commands from the remote machines. You understand the setup? You understand why I have taken the remote machine? Yeah. Whatever I have discussed, everything is available in the document. Cluster setup, common commands we need to execute in the master node and worker node, and commands that we need to execute only on the master node, and how to set up a remote machine with the kubectl to execute the commands. Is this clear, guys? So if you are able to execute kubectl get nodes, again, see here, again it failed. Previously same command we got the output. Now the same command is not giving the output. So intermittent issues we are getting with this. So earlier when I execute kubectl get nodes, I got the nodes data. After 2 minutes when I execute the same command, I'm getting a issue. Got it? It may be because of the versions that issues we have. Let me restart it once again. Kubelet. Yeah, now I am getting this. So whenever we are getting this refused, so I'm just restarting my kubelet service. So whenever I restart my kubelet service, not here, here I'm just getting the nodes, kubectl get nodes. Now again it failed. There is a serious bug here, man. Why it is failing this many times? I have restarted kubelet. Again the connection is refused. See here, same command we got output first time, and second time again it is saying that failed. There is a bug in this cluster. Let's execute kubectl get nodes here in the master node. Kubectl get nodes here also it is failing. Why it is failing here? Restart in the master node. Kubectl service, then kubelet service, kubectl get nodes. Kubectl get nodes. Yeah, maybe it is getting restarted, sir. That's why it is not giving. API server is shutting down because I have executed the restart command, right? It may take some time. Refused. Did you specify the right host or port? Get nodes. Restart it. Let's try from here. Here also it is giving issue. Let me check it. Let me find out some permanent fix for this issue. Why it is failing these many times. Okay, so fine. So with this, we are done with our Kubernetes cluster setup now. So before going to start working with Kubernetes cluster, we need to understand some core components of the Kubernetes. We need to understand core concepts of the Kubernetes like container, pod, namespaces, services, deployments that we need to understand. Core components of the Kubernetes. Okay, so we are done with Kubernetes cluster setup. Now let's understand Kubernetes components. Okay, so when we go for Kubernetes, some terminology that we need to understand first. Kubernetes core components. I can say Kubernetes having some resources, or I can say some objects are available, some workloads are available in Kubernetes. We can say that Kubernetes resources are, I can say them as objects, or we can call them as workloads. Okay, what is the most important thing here? Container. Mainly we are using the Kubernetes to manage our containers. So container will be available. These containers we are going to execute in the pod. Pod is a small unit that we can execute in the Kubernetes cluster. So logically, we are going to group the containers. One logical group of containers is called as one pod. And for the pod's execution, we are going to use namespaces. Okay, namespaces we are going to use. Then services will be available. Service will be available. Deployment will be available. Replication controller will be available. Replication controller will be available. Replication set will be available. Replication controller, replication set, and daemon sets will be available. Okay, persistent volumes will be available. Persistent volumes will be available. Stateful sets will be available. Stateful sets will be available. Role will be available. So these are the core components of the Kubernetes. Okay. Now, when you want to manage your application by using Kubernetes, so when we want to manage that application by using Kubernetes, we need to understand all these core components of the Kubernetes: containers, pods, namespaces, services, deployments, replication controllers, replication sets, daemon sets, persistent volumes, stateful sets, roles, secret config maps, load balancing. All these things will comes into picture. Okay, now here we are going to run our application by using Kubernetes cluster. Kubernetes is used to manage our containers, right? Why we are going for Kubernetes? We are building our application by using Docker. So Docker is a containerization platform. We are using Docker to create containers for our application. Docker will be used as a runtime engine in the Kubernetes. Docker will be used as a runtime engine in Kubernetes cluster. Got it? We are using Docker to create containers for our application. So Docker will be used as runtime engine in Kubernetes cluster. Kubernetes is used to manage our containers. Docker is already available. By using Docker, we are creating containers. When the container we are creating by using Docker, then why we need to go for Kubernetes? Kubernetes is used to manage our Docker containers. Kubernetes will manage the containers, but not directly. Kubernetes will manage our containers, but not directly. Directly, it is not going to manage our containers. Kubernetes will be wrapped. Kubernetes is going to wrap our containers into one unit that is called as pod. Are you guys getting my point here? Here, if you see the diagram, Docker we are using as a runtime engine. Docker containers we are going to have. Kubernetes we are using to manage the Docker containers. But the thing is, Kubernetes will not manage our containers directly. Kubernetes is going to wrap our containers into one unit that is called as pod. Okay, guys. Kubernetes we are using to manage our containers. Kubernetes we are using to manage our containers, but Kubernetes is not going to manage the containers directly. Kubernetes will use a concept called pod to manage our containers. It will use pod. It will use pod to manage containers. Got it? So already we are using Docker to create the containers for our application. Docker will be used as a runtime engine in the Kubernetes cluster. Kubernetes is used to manage our Docker containers. Kubernetes will manage our containers, but not directly. Kubernetes will use a topic called pod. Okay, what is a pod? Pod is a smallest building block. Pod is a smallest building block. Building block which we can deploy in Kubernetes cluster. You understand? If you want to run your container in the Kubernetes, you cannot run that directly. You need to use a pod concept. Pod is the smallest building block which we can deploy in Kubernetes cluster. In Kubernetes cluster. In Docker, container is the smallest part that we can deploy. In Docker, container is the smallest part that we can deploy. Whereas in Kubernetes, pod is the smallest part that we can deploy. Understand my point? When we go for a Docker, container is the last part. So container is the smallest part in the Docker that we can deploy. But when it comes to the Kubernetes, directly Kubernetes will not deal with the containers. Kubernetes will deal with a concept called pod. What is the pod? Pod is a smallest building block which we can deploy in Kubernetes cluster. Containers will be wrapped. Whatever the containers you want to run in the Kubernetes, containers will be wrapped under one unit called pod, logical grouping. Logical grouping we are going to do for our containers in the Kubernetes by using a pod concept. So if you want to run any container, you need to run that by using pod. Okay, so before going to understand the pods, we need to understand namespaces in the Kubernetes. To get clarity on pods, we need to understand namespaces first in Kubernetes. Are you guys getting my point? Pods are available. We are going to use the pods. Pod is the smallest building block that we can execute in the Kubernetes cluster. Docker is going to run the container as the smallest process. Docker container is a process. Here, pod is a process in the Kubernetes. One pod can contain multiple containers. Single container pod, multi-container pods we can create. So everything will be executed as a pod in the Kubernetes. Kubernetes pod is the smallest building block that we can deploy in the Kubernetes cluster. You see in the diagram, are we executing the containers directly on the worker node, or we are wrapping the containers inside the pod? If you see the diagram, you can understand. Kubernetes directly executing the containers on the worker nodes, or Kubernetes executing by using pods inside the pods. Pod is a smallest building block that we can execute. But to understand the pods, first we need to understand what is namespaces. Okay, what is namespace? What is a namespace in the Kubernetes cluster? Namespace. Got it. Namespace represents a cluster inside the cluster. Guys, Kubernetes namespace represents a cluster inside another cluster. Namespace represents a cluster inside another cluster. Kubernetes components will be grouped as one namespace. Kubernetes components will be grouped logically using namespace. Guys, for developers, it is easy to understand. Note, we can consider namespace as a package in Java. In the Java, we are going to create multiple classes, right? Are you going to create all the classes in one package, or we are going to group the classes into multiple packages like controller packages, service packages, DAO package, controller package, service package, binding package, util package? Multiple packages will be available. So why we are going to use multiple packages? For managing them easily. We are going to create multiple packages in our project. Simple. In our house, suppose if you are creating a house, are you going to create a big room, or you are going to divide the rooms of your house? Hall, balcony, kitchen, bedroom, like that you are going to divide. Partitioning we are going to do, grouping we are going to do. So that grouping is called as namespace. So in the Kubernetes, we are going to use namespace concept. A namespace represents logical grouping. A Kubernetes cluster is available. Inside the Kubernetes cluster, I want to run one more cluster. A cluster inside the cluster is called as a namespace in the Kubernetes. Namespace represents a cluster inside another cluster. Kubernetes components will be grouped logically using namespace. We can consider namespace as a package in the Java, like DAO package, service package, okay, util package, controller package, etc. In the project, we will create the classes by grouping them logically into packages. So similarly, in the Kubernetes components will be grouped logically using namespace. We can have multiple namespaces in Kubernetes cluster. We can have multiple namespaces in Kubernetes cluster. We will execute our pods by assigning them to a particular namespace. Okay, guys. Now, so let me go to my remote machine. Now, let me execute kubectl get nodes. It is not connecting. Yeah, kubectl get namespaces. So this is refusing our connection. Let me go to master node, restart it. Why this issue is coming? Guys, are you people getting the same issue when you execute kubectl get nodes in the master? Are you guys getting the same issue? Yeah. So here I will check that we can have multiple namespaces in the Kubernetes cluster. So we can get the namespaces of our, we can get all the namespaces. We can get all namespaces using below command. We can get namespaces using below command. What is that command? kubectl get namespaces. kubectl get namespaces. All the namespaces which are available in our cluster, or else you can execute like this also. kubectl get ns. Ns represents namespace. Namespace represents logical grouping of Kubernetes components. Okay, so one pods, services, deployments you can group as one namespace. kubectl get namespaces will give you all the namespaces which are available. Okay, right. Now when we install the kubectl, by default 3 namespaces will come. Whenever we set up the Kubernetes cluster, we will get 3 namespaces by default, but it is not recommended to use those namespaces to run our applications. We will create our own namespaces to run our applications. When we set up Kubernetes cluster, our Kubernetes cluster, we will get 3 default namespaces. 3 namespaces. What are those? First one is default. If you don't specify any namespace, by default it will take as a default. Next one is kube system, and the third one is kube public. Namespace represents a cluster inside another cluster. Kubernetes components will be grouped logically using a namespace. Component in the sense it can be a pod, it can be a service, it can be a deployment, it can be a container, right? Components will be grouped logically using namespace. So to understand in simple way, you can consider that as a package, a logical grouping. We can have multiple namespaces in the Kubernetes cluster. If you want to see all the namespaces of the Kubernetes cluster, we can go for kubectl get namespaces, or instead of giving the namespace lengthy name, you can just give ns. Ns represents namespace. Okay, guys. Now, when we set up our Kubernetes cluster, we will get 3 namespaces. We will get below 3 namespaces by default. These are default namespaces which will be provided by our Kubernetes cluster. Default namespace, kube system, kube public. So now it is not recommended to run. It is not recommended to run our pods using default namespaces. Using default namespaces, we have to create our own namespace to run our pods. Got it? Okay, so default namespaces are available for beginners. They are available, but it is not recommended to use their namespaces, the default namespaces, to run our application. Okay, guys, so we need to create our own namespace. So how to create our own namespace? Create our own namespace. Create our own namespace. So to create our own namespace, so we have a command here, kubectl, a CLI software, kubectl create namespace. You can give name, namespace name, like this. You can give it. Create our own namespace. Kubectl create namespace. For example, I want to create a namespace for my project. Kubectl create namespace of SBI customer application. Okay, SBI customer application. SBI having a customer project. So all the deployments related to customer application, I am keeping in one namespace. Okay, guys. Now we are using SBI net banking. That is a customer application. All the application related things will be available in this. If you go for SBI bank, they will use one more application that is called agent application. So SBI customer application is available. SBI agent application is available. Agent application means it will be used by SBI employees in the bank. SBI is one bank. In the SBI, multiple projects are available. One is we are using customers. We are the customers of the SBI. If you have an account, you are a customer of the SBI. You can use SBI application. That is a customer application. But if you go for SBI bank, agents will use one application. Okay, so customer application will be available as one namespace. Agent application will be available as one namespace. Okay, guys. And SBA people want to do some reports. SBA people want to do some reports. SBA report namespace, report application available to understand how many transactions happened today, how many international transactions happened today with our SBI banks. Okay, branch wise, how many transactions happened, state wise, how many transactions happened, local transactions, internal transactions, all these things I want to understand. SBI bank, government bank want to understand the transactions. So assume that three different applications available in the SBI. Now customer application will be grouped as one customer application related components, the pods, the containers, the pods, everything which are required for a customer application will be available as one namespace. Agent application having several containers, several pods are available, they will be grouped as one namespace. SBI report application is available, the SBI report application related pods and containers will be grouped as one namespace. You understand why we are going to use multiple namespaces and what is a namespace? Namespace represents a cluster inside another cluster. Kubernetes components will be grouped logically using a namespace, right? We can have multiple namespace in the Kubernetes cluster. We can get all the namespaces using below command kubectl get namespaces, or you can go for get ens. It will give all the namespaces. When we set up our Kubernetes cluster, we will get below three namespaces by default. Default namespace, kube system namespace, kube public namespace. Okay, if you don't specify anything by default, if you don't specify anything by default, it will take the default namespace to run our pod, but it is not recommended. Okay, so in the project, we are going to create our own namespace to group our Kubernetes components logically. How to create our own namespace in the Kubernetes? kubectl create namespace, namespace name. So in one project, we can have multiple namespaces. For example, SBI customer application available, SBI agent application available, SBI report application available. Customer application related pods, I will group under one namespace. Agent application related pods, I will group under one namespace. Report application pods, I will group under one namespace. It is a logical grouping for the better management. Logical grouping for the better management. We will run our pods under one namespace. We will run our pod. We will run our pod using custom namespace that we are going to create. We are going to run the pod by using custom namespace. Okay, how to get the pods or belongs to particular namespace? How to get pods belongs to a namespace? Okay, here I'm going to specify kubectl get pods, kubectl get pods -n namespace name, getting pods from all the namespaces. How to get the pods of all namespaces? How to get the pods of all namespaces? kubectl get pods all namespace, so it is going to give you the pods which are belongs to all the namespaces. It will give you the pods belongs to a particular namespace. We are going to run the pod by using a namespace. Okay, now let me go here, kubectl get namespaces. Now you see currently namespaces are available. Now let me execute. Now it is working. Again it is gone. Arre Baba, what is this? Just now it worked. I cleared my screen. Namespaces. Guys, there is some issue here due to maybe some version issue or something. Sometime it is working, sometime it is not working. Just now, first time it executed, second time it failed. There is a serious bug here. First time it executed, second time it failed. Get nodes, get namespace. Yeah, fine. So we'll see that what is the fix for that. So here we can create our own namespace by using create namespace command. Then once you create a namespace, then we are going to run our pod by using a namespace. How can we check the pods belongs to a particular namespace? kubectl get pods a namespace name. If you want to get the pods belongs to all the namespaces, then you can use kubectl get pods all namespace. It is going to give you the pods of all the namespaces. Are you guys clear with my point? Are you guys clear with my point? What is a namespace in the Kubernetes cluster? Are you guys clear with what is a namespace in the Kubernetes cluster? Just read this data, read this information. What is a namespace in the Kubernetes cluster? Guys, I told you it is little challenging to understand the Kubernetes, but we have to. There is no alternate. There is no alternate. There is no alternate. Namespace means a group of Kubernetes components. Default 3 namespaces are available, but it is not recommended to run our application with them. We need to run our application by using custom namespace. How to create custom namespace? kubectl create namespace command is available. So in the project, multiple namespaces will be available. I have given a scenario why we will go for multiple namespaces. Kube SBI customer application available, agent application available, report application available. We are managing 3 applications of SBI. So this application related components will be available under one namespace. Agent application components will be available under one namespace. Report application components will be available under one namespace. So once you have created a pod by using a custom namespace, how can we check the pods belongs to particular namespace? kubectl get pods namespace name. If you want to get the pods of all the namespaces, then kubectl get pods all namespaces we are going to give. It will give the namespaces. Let's try. Yeah, now you see kubectl get namespaces. Now we are getting default kube system kube public. Now let me go for kubectl get pods of kube system. Kube system kubectl get pods kubectl get pods of kube system. Now can you see in the kube system all the pods are running? Can you see all the pods which are running in the kube system? Kube scheduler is running, kube proxy is running, kube control manager is running, kube API server is running, etcd is running. These all are core components of the control plane. If you see our control plane, API server, scheduler, controller manager, etcd, these all are running as a pods in under one namespace. What is that namespace? Kube system namespace. The default components of the control plane are running as pods. API server is one pod, scheduler is one pod, control manager is one pod, etcd one pod. All these pods are running under one namespace. What is that namespace? That is kube system default namespace. Okay, is it recommended to run application pods under kube system? Is it recommended to run our application pods in the kube system? No. What is the purpose of kube system? What is the purpose? What is the purpose of a kube system namespace? Control plane components are grouped under kube system. Are you guys clear with my point? Are you guys clear with my point? Control plane components, API server, scheduler, control manager, etcd, these 4 components are running as 4 pods. 4 pods are grouped as one namespace. That namespace is called as a kube system. Okay, now let's go to kube public. What are the pods running under kube public? Kube public namespace, no resource found as kube public. Let me get namespaces. Kube-public is available. kubectl get pods -n cube public. That is not available. No resources found in the cube public namespace. Currently, nothing is available under cube public. Okay, cube public namespace is reserved for the Kubernetes system. We should not use that cube public. We can run our pods in the default, but it is not recommended. Okay, a fresher who is not having the much knowledge on the Kubernetes cluster than namespaces, they may run the pod on the default namespace, but it is not recommended. It is not recommended. So there are 3 default namespaces available in the cluster. So one is default, another one is a cube system, another one is cube public. Default cube system, it contains Kubernetes control plane pods. Okay, right. Cube public, it is reserved for Kubernetes system usage, not recommended for using this. If we don't specify any namespace, it will be used by default when we don't specify our namespace. When we don't specify our namespace, then it will go to the default namespace, not recommended to use. Always we need to create our own namespace to run our pods. Okay guys, kubectl commands we are using to check the existing namespaces. Now let me get the pods of all the namespaces. kubectl get pods -n all namespaces. Sorry, all namespaces. kubectl get namespaces. Yeah, kubectl get namespaces. kubectl get pods. No resources found under a default namespace. So whenever I execute kubectl get pods, by default it is going for which namespace, guys? Default namespace. Okay, so getting all pods of default namespace. When we don't specify any namespace to get the pods, kubectl get pods, it is pointing to default namespace. If you want to get particular pod names, particular namespace pods, you can use this. If you want to get all the namespaces pods, you can go for this one, right? Default namespace is also available, but it is not recommended to use them. We are going to create our own namespaces and we are going to use that. How to create our own namespace? Here, kubectl create namespace test app. I'm creating one namespace with a test application. So all my components will be grouped to the test application. Like this, you can create our own namespaces. Resource quota validation time dot. Okay. Why these many issues? kubectl create namespace test application. I mean test app. Like that, I'm going to create one namespace. Is this issue solved here? Timed out we are getting. API server is shutting down. kubectl get nodes. How many times we need to restart this, man? Restart the kubectl service. Get the nodes, namespaces or nodes, whatever. Yeah, fine guys. So here we are going to use a command to create our own namespace. So once we create our own namespace, we will bind our pods to that namespace and we are going to run. When we delete a namespace, suppose now I have used one namespace called SBI customer application. If I delete this namespace, what will happen? all the components belongs to that namespace also gets deleted. If we delete a namespace, all the objects or resources or components also gets deleted. Whatever the pods, whatever the containers which are running under namespace, everything will be deleted if we delete a namespace. If we delete a particular namespace, suppose for example, I'm deleting SBI report application namespace, then all the pods, all the containers which are belongs to that namespace, all the objects, all the resources which are belongs to that namespace also gets deleted. Also gets deleted. Are you clear? Are you clear with my point? What is a namespace? Good. So with this, we got the clarity on namespace now. So tomorrow we are going to create a pod and we are going to run the pod by using namespace. Got it? So now we need to create a pod, and that pod we are going to create by using namespace and we are going to execute it. Fine, guys. So please practice this setup, whatever we have done along with the remote machine. So we created a remote machine. So please go with the remote machine and practice it. Now, after restarting the kubelet, now I got the nodes. Okay, let me create a namespace now. Namespace test application. Now you see namespace test app got created. What is the command? kubectl create namespace test application. Now get the namespaces. kubectl get namespaces. Now you see here test app namespace got created by default. Created. This is our custom namespace I have created with a name called test app. Now kubectl get pods -n namespace is a test app. Again the connection is refused. Kya ho raha bhai? We can get the pods belongs to particular namespace. So we created a namespace. So I want to get the namespaces. I want to get the pods which are belongs to that namespace. This is the command we can use. So a lot of issues we are getting in the local setup. Right. We are going to create the pods inside the namespaces. Namespace is a grouping. Okay. Fine. So please practice this remote machine setup and try to operate the commands. Try to use the kubectl commands from the remote machine. So I'm going to update the installation document. There I told you how to install the kubectl in the remote machine. Once it is done, so create a namespace and try to execute some commands related to the namespace. So tomorrow we are going to create a pod by using this namespace. Tomorrow we'll understand what is pod lifecycle, how to create a pod, how to execute a pod. Those things we will discuss in the tomorrow session. Okay. Thank you guys. We'll meet again in the tomorrow session. Bye bye. Docker nodes I have already uploaded, sir. People, I have seen lot of kachda is happening in the group. Docker nodes I have already uploaded in the website. Why are you asking again and again? Latest Docker nodes I have uploaded. Docker Swarm nodes also I have uploaded. Somebody is sending a message, nodes is not uploaded. Check it now. The latest nodes already I uploaded 2 days back. You are sending a mail ID, somebody is sending notes to your mail ID. What is that? Already we have a portal. Everything is already available in the portal. So let me show you. The notes, complete notes is already available in the portal. Then why again and again you guys are asking? I don't know. Don't you know how to check the portal? If you go to our website, if you go to this, if you see here, Docker notes completely I have uploaded. See the end. Completely Docker file is available here. Docker Swarm is available. Docker Swarm also available. The Docker Swarm nodes also I have given here. Okay. So please check it in the portal. Fine. Thank you.